Hello students, today we are going to study the some terms related to the basic communication system. So let us start with this definition. Communication system basically helps in transmitting the data from one end to the other through a proper medium or channel. Based on the direction of transmission and reception of the system, system classified in the two domains. The first one is the unidirectional system, that is a simplex system, and bidirectional system or duplex system. So suppose if you are the sender and receivers wants to communicate with each other, senders wants to send some information to the receiver via the some proper channel. So that sender can use the simplex communication or duplex communication. Simplex communication we can call it as unidirectional system, and duplex communication we can call it as a bidirectional system. So depending upon there may be the half duplex system and full duplex system. Communication system based on the direction, it can be simplex, half duplex and full duplex. Simplex communication system. In this system, one-way communication, as it is only capable of transmitting the data, as it is unidirectional transmission, this system never needs an acknowledgement from the another end, and the result in negligible return. So if there is a one transmitter wants to send the some information to the different receiver. So transmitter sends the information to the antenna or channel, and that antenna will send that or broadcast that message to the different receivers. That is nothing but the unidirectional system or simplex system. In this system, there is a one transmitter and the number of receivers are there, and receivers only accepts the information. There is a no acknowledgement is there or no feedback is there. So the results in negligible return. The best example we can have in the simplex system is the television or radio system, where televisions transmits the information to the different customers or receivers. Same way for the radio system transmits the information or channel information to the different customers. That is source of the data or information is a transmitter, and other end where the data is collected is the receiver of the system. So the best example is the television and radio system. During the transmission of the information of or a signal in TV system, the transmitter simply transmits the signal irrespective of the acknowledgement. That is, that transmitter does not require any acknowledgement or feedback from the receiver, and it is the properly received or not, as the receiver at the destination is not able to send the back anything towards the other end. This is the type of the transmission is not widely used, as it is a one-way communication. The error in the signal is received at the destination cannot be reported. So if the any receiver gets error while the reception, that acknowledgement process or feedback process is not available there. So this is the one of the drawback of this communication system. The sum goes with the case of the radio system, in which the audio signal is transmitted and get received by the listeners on the destination end, but they are not capable to send back any information regarding the proper reception of the signals. And during the transmission of the data, the power of data transmission must be compatible with the distance through which the data has to travel. If the distance through which the data has to travel is higher, the required power for the transmission must also be the higher. The advantage of this simplex communication is it is easy to install, and structure of the system is simple. This is the first advantage. As the system supports the one-way transmission, the whole bandwidth can be utilized. And as advantages are there, there is a one disadvantage also. The chance of interference in the signal due to the noise and crosstalk are more due to the ground returns. So this is about the simplex transmission or system. Next one is the duplex. As it is clear from the name itself, the duplex means dual. This system allows the two-way communication. that is from the both end. That is, here the transmitter plus receiver, bidirectional flow of information and communication link, and the transmitter and receiver at the end. So two-way transmission or communication is there. Half duplex. Due to bidirectional nature of the communication, the transmission and reception both can be done but not in similar time domain. So at a time they cannot talk or communicate with each other. So half duplex, in half duplex, that is due to the bidirectional nature of the communication, the transmission and reception both can be done but not in the same time. It is basically two simplex system that operates in opposite direction. That is nothing but the duplex system, but the frequency of both end must be the same, so that so as to transmit and receive the data properly. Walkie-talkie represents the best example of half duplex system because both connect both the connected ends transmits the information to the each other, but only after the acknowledgement or completion from the other end, till the receiver at the other end waits for the opportunity to get an acknowledgement. And needs of the transmission power is according to the distance, as if the power is not according to the distance, then the destination will not get the transmitted data properly. So this is the half duplex system. Advantages is low in cost as compared to the other duplex mode, and disadvantages, it is slow mode of the communication as it requires the acknowledgement from the other end. Now turn to the full duplex system. This system provides the transmission and reception from the both the end simultaneously. In this system, two different frequencies is to be used to transmit and receive the data in similar time domain. During the transmission and reception of the information or signals simultaneously in this system requires more than one physical channel. The best example is the telephone system. The telephone system best describes the examples of the full duplex system of the communication. During the phone call, the two end parties on call does not need to wait for any indication before they transmit the information, as this is an acknowledgement free transmission. This system comes under widely used range because it makes the transmission interruption free as well as gives the faster way of the communication. Transmission power puts a great impact on the transmission of the signal, as it is totally depend on the distance that the signal has to travel, because more distance, higher the transmission power is required for the particular transmission. So in the full duplex, the two parties can talk each other without any acknowledgement and simultaneously in same time domain. So the telephone system is one of the best example of full duplex system. So two parties can transmit and receive the information simultaneously. This is widely used application. This is the interruption free application and faster way of communication. But as the distance increases, the transmission power is required, the higher transmission power for the higher distances for the particular transmission. Advantages: this system permits an increase in efficiency in the communication, but the disadvantages is results in decrease in the bandwidth, and the communication relies on the various factors, but most important factor is the direction, as the flow of the signal in a particular direction gives us the best way to conclude the transmission and reception phenomena. Modulation. So this is the basic term which we should know before the starting of the digital communication theory. Modulation. Modulation, the process in which the carrier signal is varied according to the information bearing the signal, is also called as a modulating signal. During the modulation, some characteristics of the signal, it can be amplitude, frequency or phase, is varied in accordance with the original information bearing signal that has to be transmitted. The receiver at the destination end won't able to understand the particular modulated signal, so it uses the demodulated section and demodulates that signal, so get the original baseband signal. Suppose this is the block diagram or basic modulation system, that is a information bearing signal or modulating is fed to the modulator, and the second signal to the modulator is the carrier, where the amplitude, frequency or phase is varied according to the signal, modulating signal, and you will get the modulated signal. Next, what is baseband signal? Baseband signal is nothing but the original signal that the user actually wants to transmit, which is uncovered, unconverted, or the we can say the unmodulated. This unmodulated signal generally occupies the frequency spectrum from 0 Hz, we can see in the picture given below, 0 Hz to the FM up to the frequency. Let us take an example to make it clear. An audio signal have the baseband range from the 20 Hz to 20 kHz during the transmission. When the signal is modulated, it goes to the higher inaudible range, which cannot be normal audible range. When any baseband signal is transmitted, such as a telephone network or where the electrical signal of sound signal is directly placed on the telephone lines for the transmission, it leads to the several difficulties in the communication, and that can be effect of the noise or crosstalk. This is the only reason why we convert the baseband signal into the bandpass signal. Next, bandpass signal. When the baseband signal is modulated or converted so as to transmit it to the longer distance, it is known as the bandpass signal. That is, the baseband signal is converted for the transmission purpose. It is that signal can be called as a bandpass signal. This signal have the non-zero lowest frequency in its spectrum. The frequency band of this signal is not adjacent to the zero frequency. So its frequency is non-zero lowest frequency, and the frequency band of this signal is not adjacent to the zero frequency. The radio waves and ultrasound waves, they suit an example for the bandpass signal. During the modulation, the carrier signal which we use is basically a carrier which carries the modulating signal from the end to the other end. The best example, when person rides his or her bicycle, the person can be assumed as a signal to be modulated, and the bicycle can be viewed as a carrier signal. So carrier signal carries that signal, baseband signal. Next, why demodulation is required. During the modulation, we have discussed earlier that the low frequency signal is modulated to the high frequency signal, which ultimately gives us the several advantages during the transmission, which are discussed here. The first advantage need is the highest antenna is reduced. When we transmit the radio signal, antenna height must be multiple of the lambda by 4, where lambda is the wavelength whose value is the c divided by f into lambda, and is directly proportional to the speed of the light and inversely proportional to the signal frequency. This means that higher the frequency, lesser will be the value of lambda. That results in the shorter height of the antenna, which can be particularly installed, and thus we can say that the modulation reduces the antenna height. This is the first need of the, that is to reduce the antenna height. Second need is avoid the mixing of the signal. It avoids the mixing of the various signal. Suppose we have transmitted some baseband signal by multiple transmitters, then all signal will be in between the same frequency band, that is between the 0 to 20 kilohertz, which results in the mixing of the signal, and receiver will not able to separate them. But if we modulate all the signals with the different carriers, then the signal will have different frequencies range, so they can be easily separated at the destination end. So modulation avoids the mixing of the signal. Third need is increase in the range. Low frequency message of the message signal has another drawback. It cannot be traveled much longer distance during the transmission as signal gets attenuated. So if we increase the frequency, then the attenuation gets reduced and thereby increasing the range of the data transmission. Next, multiplexing can be done. If the signal modulation makes the multiplexing possible through the multiplexing, we can use the same channel to transmit the various signal at the same time. So multiplexing possible, but gets successful only when the signal is modulated, because the modulation provides the different frequency range to the signal and due to which they can be transmitted through the same channel at the same time. So multiplexing can be done through the modulation only. There are different types of the modulation. So depending upon the angle, so angle that angle modulation, the amplitude modulation used. It is a process in which the amplitude of the carrier signal gets varied according to the amplitude of the message signal. This mode of the modulation is very simple and straight way to modulate any baseband signal. It is most effective and easiest way of the modulation. Suppose this is your baseband signal and this is your carrier signal. So the carrier signal is modulated or changes according with the baseband signal. So you will get the amplitude modulation. Next, frequency modulation. This type of the modulation has mainly its application during the radio communication, FM. When the frequency of the carrier is varied according to the amplitude of the information bearing signal, then the modulation is known as a frequency modulation. Here the carrier amplitude remains constant. Here amplitude remains constant. In this, information is carried by the frequency variation. The most important factor is the amount of the variation of the signal. Better SNR can be achieved through the FM as compared to the AM in case of the wider bandwidth. So this is the baseband signal, and the carrier it changes according to the baseband signal. So okay, in carrier there is some low frequency components are there, and sometimes there is a high frequency components are there. So the information or the frequency changes according with the baseband signal. Next one is the phase modulation. These are the some types of the angle modulation, that is amplitude, frequency and phase. Here the phase shift of the carrier is varied according to the amplitude of the carrier wave. When we apply the phase modulation, it leads to change in frequency too. So phase modulation. So here the phase it changes from the negative to positive. There is a phase positive, and from the positive. So here is again one phase it changes. That is a phase modulation. The pulse angle modulation. Pulse angle modulation. In pulse modulation, the carrier is in the form of pulse rather than being a sine wave as in other type of the modulation. Pulse amplitude modulation or PAM. In this amplitude of the carrier, which is in the form of pulses, is varied according to the amplitude of the modulating signal. Next one is the pulse width modulation or PWM. The width of the pulsed carrier. Here carrier is pulsed signal. So width of the pulsed carrier is varied according to the amplitude of the modulating signal. Next one is the pulse position modulation, PPM. That is position of the pulse is varied according to the information bearing signal in the pulse position modulation. Thank you.